All right, everybody. So, yes, once again, a very good morning, everyone present out here. Greetings of the occasion, ladies and gentlemen. Welcome back to Shanghai Corporation Organization First Young Scientist Conclave 2020, Day 4. Well, let us continue with our session on combating COVID-19 and emerging pandemics through research and innovation. So I may welcome back our chairs for the session, Professor Dr. Manmohan Mendirata and from Janakpuri Super Speciality Hospital, New Delhi, India, and Dr. Anant Mohan, Professor and Head Department of Pulmonary Critical Case and Sleep Medicine, All India Institute of Medical Sciences, India. Welcome, both of you. So
Hello,
I
good
would
morning.
like to convey that if there is any delay or any interruption in the presentation, our team would be waiting for only 30 seconds. And in case if it's not ready even then, we shall proceed with the next presenter because of the time schedule which we have packed up in. Also, all the young scientists are requested to actively take part in a networking session to showcase your thoughts, your ideas for future collaboration. Based on this networking session, one or more presenters have to present a roadmap for the next 10 years. So make sure you're being very attentive, at the same time enthusiastic. Also, we have with us the presenter of the day, Dr. P. Anton from Southern Federal University, Russia. So, yes, I would like to welcome all of you, and we are back with the session which we left yesterday. So, let's continue the Spirit Zone in, please. I would like to welcome our presenter of the day, Dr. P. Anton from Southern Federal University, Russia, to please take over the forum.
Palviji, then we go to next.
All right, so we are moving to our next presenter, Dr. Pakulova Ekaterina from Southern Federal University, Russia. Again, can you please take over the forum?
Good day, dear colleagues. My name is Ekaterina Pakulova and I am from Southern Federal University of Russia Federation. Today I'm going to tell you about multimodal communication for monitors of the health status of the person. So let's start. Today, multimodal approach is relevant in any sphere of our digital life. The technologies aim to suggest the best and the most comfortable way for human-human and human-machine interaction. One of the directions to do that is the usage of multimodal communication. The new possibilities in technologies have opened up a new research field of multimodal interaction. The multimodal system allows us to design various adaptive or multimodal monitoring systems. This system interacts with the user or monitor human's condition, for example, smart home, smart vehicle, a health system, or it may use biometric parameters for security purposes, such as authentication. The term modality itself is not overly informative. There are maybe a lot of variants. In this research, we understand the term modality as belonging to this reflected stimulus to the specific sensory system, part of the human nervous system, responsible for the perception of particular signals from the environment or internal environment. Modalities allow to identify and monitor the physiological state of the user. Multimodal interfaces allow for a joint input of information from the variety of different sensors, passive and active form of the user input. The multimodal approach may help us to monitor the condition of the person who is ill with COVID-19 or flu or any other disease through various sensors, smartphones, smart vehicles, and so on. And here, distinguish two scenarios. The first one is for illness detection, and the second one for monitoring for health condition of the ill person. So first of all, we outline the possible communication channel for illness detection. It is an acoustic communication channel which combines vocal, it means paralinguistics, and extralinguistic channels. In the vocal channel, messages are transmitted via the verbal channel. It means speech. And in the extralinguistic channels, it transmits coughs, sniffles, sneezing, and etc. For the speech, it is also possible to extract the heart rate of the person. We have such research. The visual communication channel conveys the external biometric differences of the user and the manifestation of his behavioral characteristics. Facial expression, for example, features, body movement, etc., through photo or video recording by various technical devices. It allows to analyze both unique static and dynamic identifiers, as well as considering their combinations. Through the visual communication channel, we may control body temperature, eyes control, and tearing. Haptic communication channel allows to monitor oxygen saturation and blood pressure. We consider the system for monitoring the health status of the person and population as a client-server framework. A multimodal device measures the characteristic of the user, generates data packets, and sends them to the data preprocessing and storage center. The physical parameters of the user may be extracted by multimodal interfaces of various sensors, including Internet of Things. The expert system analyzes them and presumes diagnosis, after which it offers to make an appointment with a specialist, or if an urgent condition is identified, calls an ambulance. Information about the specialist shelter and the time appointment's availability is sent to the system server in real time from the database of hospitals. Further, all information about the patient received by the system is stored in the database on the server. It is available for medical specialists for confirming the diagnosis or making changes at the workplace. The task of multimodal information transmission is in the information system of special interest. Under the architecture that mobile user terminals have access to information system, the data transmission takes place in unstable network environments or in the condition of the user movement, where mobile user's terminal doesn't have a permanent access to the fixed access point to the network. Moreover, the usage of wireless network technologies is more vulnerable to security threats that are more important for multimodal information. One approach to mitigate the problem is to dynamically offload part of the traffic to another technology that supports good network condition. Offloading can be performed seamlessly by deploying multipath transport protocols that incorporate mechanisms to distribute the load of the available network interfaces. Thus, users' application works with different access networks in the heterogeneous and wireless simultaneously. The area of my research interest lies in multimodal interaction and multipath data transmission in heterogeneous wireless networks. Also, its assessment of its quality of experience and quality of service. I see possible way for joint work as a common research project, which may be supported by various funds or maybe by SCO countries if they have such a program. For sure, it is very important to know people face to face, and that is why it is very important to have the visiting program, some acquainted program for teaching and research. And since we have strict restriction about visiting other countries because of the pandemic situation, at the first time it could be online panel discussion through the year. For this purpose, the special person, let's call him or her facilitator, who can organize such discussion for some special topics. So now some words about my university, Southern Federal University. It is today situated on the south of Russia, on the border with Ukraine. And it is one of the fifth federal university of Russia. We have more than 18,000 students, and we have a really variety of directions of scientific and educational activities, such as photonics, nanomaterials, and nanotechnologies, biotechnologies, medicine, information and telecommunication technologies, marine aviation and space rocket, also architecture and art and humanities technologies. If you're interested in it and you want to be acquainted with our university, you may go to sfeda.ru. So thank you for your attention. So I'm here. Any question? Do you hear me? Yes?
Yes.
Yeah, you are audible. If there
Okay.
are any questions from the floor or through the chat box,
Yeah, so we do have a couple of questions from the live audience.
Okay.
the mic is not working.
Hello. It's
Hello.
a great work actually, and I do appreciate that. So I think this multimodal communication is, I think, way forward to distinguish and to understand a lot of diseases like Parkinson's and those diseases. So I have one question, like since this is kind of app-based, or whatever I understand, and can you distinguish, say for example, between viral fever and other fever using this model, and how to go forward with that? Because say for example, if somebody has most of the diseases, like even in COVID-19 also has very common symptoms, so how do you differentiate using this multimodal communication techniques? Thank you.
Okay, thank you for your question. I think that, for sure it's a very difficult question because it's very difficult to distinguish the particular symptoms, because you're right that they are common. So this system is actually, then you have some markers of the disease, for example, or for any other physical state of the person, and just to understand that the situation, for example, is critical, or you may distinguish the path for doctors. I mean, the way of possible situation. For example, if a person have the high temperature, some problems with the blood pressure, with oxygen, so it's one situation. For example, it may be with the high temperatures, it's not a heart attack, or it's some flu or cold and so on. So it just today it is important to understand the state of the person in the distance, and the multimodal interfaces allow us to do that. But for sure, to be to know the diagnosis, so to my mind, it should doctor says, because so this system just may give to doctors the direction of their thinking, of their research on the state, no more, because the particular diagnosis and the particular situation should be decided by a doctor. Yes, but I don't know how in India, because of the COVID situation in Russia, we have a really great problems. I mean, because here are a lot of people who are ill, and we have a few doctors, and some electronic system may help us to understand, is the situation critical or not? Because people sometimes, can be panic without any problem. That's all. But and I may also add, that the system is very flexible, because you may distinguish the particular modalities for each situation and for each problem. So you may choose what modalities is, or what modalities is more important or not. And the second step, we want to arrange these modalities, or with the priority that one modality will be more prioritated than others, and then the model will be more precise. Yes. Okay. Thank you. Is it okay?
All right, Doctor, thank you so much. Well, here we'll be moving to the next presentation, everyone. So now may I again request Dr. Beljonkin Anton, Southern Federal University, Russia, to please take over the forum. So are you available right now?
Yeah, dear participants, I'm very glad to see you all. So I share my presentation. Are you see?
Yes, we can see your presentation. Please go ahead.
Okay. Topic of my research is method for predicting the spread of viral.
Sorry, sir. Sorry for the interruption. Can you please switch on your camera because we can't see you actually.
Just a moment, my camera.
Yes, please go ahead. Yeah.
Okay, super. Topic of my research, a method for predicting the spread of viral diseases using big data. Okay. What problem are scientists facing? We cannot predict the spread of viral diseases. We realized this long ago, but now it's very relevant. Ebola has killed about 20,000 people. There are several facts that prevented this disease from spreading. It was in Africa, and Ebola is quite difficult to get infected. But what do we see when we analyze COVID-19? It is spreading rapidly, and it is very difficult to predict. We propose a method that will improve the accuracy of the infection forecast. The peculiarity of the method lies in the fact that we use personalized data. These are data such as activity on social networks, geological data, fitness trackers and other sport indicators, online shopping, include food markets, for example. All this data is open to browser and we can use them. For analysis, we use a graph model and communication coefficients. Each edge of the graph has a weight that is updated online. It's always online data. These are the coefficients of a person activity on the internet. These are personalized data sets, and all these can help to analysis. We did a simulation. Summarized results are presented on this slide. We cannot give you more detailed information yet because these works are not published. We compared our method and the CIR model. We applied our method to the SARS series and obtained, I think, very interesting results. Of course, more research is needed, and we are on the way. I'm confident that with the help of science, we will be able to significantly improve the accuracy of infection prediction. This slide demonstrates how we can collaborate between our university, between our group, scientist group. You can see this MOU, joint grants, a conference, papers, student exchange, and another points. So my name is Anton, it's my contacts. I am director of India-Russian Scientific Centers, and I've been in India 6 times, but this year was very difficult for us. Thank you very much. Are you hear me?
Yes, we hear you. I hear you.
Ekaterina.
All right, doctor. So we can go ahead with Q&A session. Any questions do we have from the live audience?
Okay, I wish you very productive work, very productive. It's very important event for all of us.
Yes, so doctors, do we have any questions or we can proceed with the next presentation? Okay, so we're going to go ahead with the next presentation, everyone. So now may I request Klitsov Sergey from St. Petersburg Mining University, Russia, to please take over the forum.
Good morning.
Good morning, doctor.
Okay. So warm welcomes from Russia. Hello, my name is Sergey Kryltsov. I am assistant of Department of Information Technologies and Computer Science at the St. Petersburg Mining University. Me and my colleagues work at the junction of the power and IT industries. Our team's goal is to deliver power to the consumers and enterprise grids with a quality that can meet local standards. The consumers typically are multi-megawatts rated power installations that are the necessary links in the chain of technological process. The most common example of such power equipment is electrical drive, which is used in a huge variety of installations. Power quality disturbances is a typical problem in industrial grids. Examples of such disturbances include voltage dips, fluctuations, asymmetry, harmonic distortion, brown and blackouts. Disconnection of power equipment from the grid due to problems with grid power quality may lead to severe losses caused by the interruption of technological process. To maintain required power quality, special compensation devices are used, which are known as flexible AC transmission systems. The novelty of our research comes from developing fast algorithms for estimation of power quality and control of power converters. That allows us to effectively use other power devices to improve power quality, like active rectifiers as a part of electrical drives, or grid-side inverters that are used in generators based on renewable energy sources. For example, we use developed control structures not only to extract maximum power from the wind, but also for stabilizing grid voltage, which helps reducing the amount of power rating for additional compensation devices. Another major area of our interest is to merge Internet of Everything approach in the industry, especially machine-to-machine communications. The primary goal of this research is to develop and integrate efficient protocols to provide data exchange between sensors and industrial control systems at different abstraction layers, especially in case of low bandwidth and unstable connections. Based on the described background, we apply accumulated knowledge and expertise combating COVID-19. So the name of the project is the web platform that is aimed to help build the infrastructure which delivers uninterruptible power supply for COVID-19 hospitals. We focused on this subject because maintaining uninterrupted and artificial respiration of patients with severe lung damage is a critical medical task, and such hospitals become the highest power consumer class. When building new hospitals, especially in the field, a lot of engineering tasks and questions are raised. Which power source to prefer and which are available? How much power is required for 24/7 full functionality of hospital? How large should be power banks to provide an uninterruptible power supply for a day? And what about a week or a month? The proposed novel idea is the web platform for infrastructure builder, which helps to provide faster response to building new hospitals. The solution is based on several blocks information. The information about existing grid infrastructure and available power sources, including renewable energy sources, lists of power and networking equipment available at the market, which can be obtained from manufacturing or from engineering society, and equipment required for COVID-19 hospital. Bringing the graphical user interface that helps to automate part of routine tasks when building such infrastructure, we reduce the time and the cost of its building. So, for example, the slide contains the graphical user interface for which we developed for building the power infrastructure which delivers uninterruptible power to the COVID-19 hospital. And we can change a lot of parameters here, like the wind turbine parameters. We can interconnect renewable energy sources with actual power grid and with uninterruptible power supplies like diesel generators. The proposed solution is based on 3 principles. The first is to automate as many routine engineering tasks as possible. All power calculations are carried out by algorithms that use information about existing infrastructure and a list of required hospital equipment. Comparing calculated data to hospital requirements, the graphical web interface allows quick prototyping of power grid and network topology, as well as guides engineers during the development of the hospital project. The second principle is templating. I'll provide several examples. Lists of typical hospital rooms equipment allows quick prototyping the hospital of necessary size. Environmental data, if being gathered at once, may be used for estimation of renewable energy sources efficiency for every adjacent area. Lists of equipment available at the country-specific markets can be applied to a number of projects of other hospitals. The third principle is sharing. Almost any gathered information during the realization of one hospital project may be reused many times. While every project will consist of location-based data, the gathered data will improve speed of building another hospital in adjacent area. The expected outcomes during pandemic mainly consider reduced cost and, what is more important, time for building COVID-19 hospitals, especially in the field and rural areas. Another great outcome is a constant improvement of methods for quick and efficient infrastructure deployment. However, expected outcomes not only limited to pandemic situation. After the full sufficient elimination of COVID-19, the grid infrastructure, which was built to provide an uninterruptible power supply for hospitals, can be transformed to microgrids, aimed to powering settlements or supplying additional power to the main grids. Developed web platform will be still useful, as to my surprise, there are no widely used or comfortable web portals which bring clear knowledge database about delivering the power of required quality. The proposed infrastructure builder might be generalist for application in other power grid projects, especially smart grids. The knowledge and code database obtained during development of the proposed project is supposed to grow further and become a great source of both general and specific knowledge for community of power engineers. Possible collaboration with SCO nations consider both technical realization of the proposed project and uniting the community of engineers with corresponding expertise, which can include experience in building hospitals and related infrastructure, integration of power sources with different parameters into the grid, development of distributed infrastructure for providing reliable access to the web platform around the world, and development of algorithms to automate prototyping of the infrastructure. Another major collaboration is expected in filling location-specific data, such as a list of equipment available at the market, details on standards for hospitals' equipment and power grids, or environmental data. So during the pandemic, we at St. Petersburg Mining University are focused on bringing the high-quality education in technical sciences. As well, we are constantly engaged in scientific research and development activities, and we are always open for collaboration. Thank you for your attention.
Thank you so much, Doctor. So, do we have any queries? I would like to request our chair if we have any question by any chance. Professor Manmohan, if you can unmute yourself.
Yeah, I'm around, and he has rightly highlighted the platform by which we can connect to the community by various modalities. And if there are no live questions or through chat box, then we can proceed to the next presenter.
So yes, I do repeat, do we have any live audience questions? I think we are pretty much clear, sir. So
I'm sorry,
can...
I am in my office, so I have to be in mask today.
Yeah, got it, sir. No issues. Okay, so can we proceed to the next presentation? I think, sir, Doctor have already made it supremely clear.
Yeah, I think we can proceed.
All right. Thank you so much. Well, ladies and gentlemen, here we'll be proceeding with the next presentation. Now, may I have Nozim John Chognov, Ministry of the Innovative Development of the Republic, Uzbekistan, to please take over the forum side.
Yes, I'm here. Can you hear me? First of all, thank you for giving the opportunity to give a presentation. So my theme is the importance of telemedicine during the COVID-19 pandemic. So the main purpose of our project is to organize the high-level medical service in rural area based on the telemedicine innovative technologies. So let me explain the project. During the COVID-19 pandemic, the mandatory social distancing and the lack of the effective treatment has made telemedicine the safest interactive system between patients and both infected and uninfected and clinicians. There will be an opportunity for the people to get medical service based on telemedicine. So the project benefits is to telediagnose and teleconsultations, cheap and high quality and modern medical service, easy for organize and economically it's saving. Remote assisting to doctors, and the coverage of our project is in Karakalpakstan region, which is situated in Uzbekistan. So we are planning to implement this project in Muinak district in Karakalpakstan. The initiators of that project is the Ministry of Innovation and Ministry of the Health of Uzbekistan. So the features of my project is to give to people the high-level medical service based on the telemedicine technologies. And also all the data will be secured in one cloud or in one server. And in the other hand, we can save the time for traveling. So on that slide, you can see the planning building of our clinic in Muinak region. That's also a plan. So on this slide, you can see the software of our project. So this is the home page of the our project. So all the data will be collected in one cloud, in one server. The server can be hosted, or you can buy the server. All the main data like blood pressure, temperature, highest weight, pulse, and also the concentration of oxygen in the blood will be collected in one cloud. So at the end of the teleconsultation, the history of the patient will be faced, and it will be collected in one data. So in order to enter to the data, you have to log in, and you have to enter your password. This is the end of my presentation. Thank you.
Thank you so much for your kind presentation. Yeah, please carry on.
Yeah, so again, if we have any live questions or any question in the chat box, we can proceed. Okay, so we have a live question over here. Mr. Nazim John, I would like to request you please unmute yourself.
Yes, I'm here.
Yes, please.
Mr. Nazim Zon, firstly, a very good presentation given by you in which you are telling about the importance of this telemedicine. My question here is, can you please tell me that what are the challenges and limitations in the developed countries we are facing that we are not properly implement this technique? Can you please enlighten some fact on this?
Okay, first of all, thank you for your question. The main problem of this project is to implement that project in other countries like Kazakhstan or I don't know, or India or Russian Federation. But currently we have already implemented that project in Uzbekistan. We have opened the clinic which is orientated to give a telemedicine service in Karakalpakstan region. It's already opened in Uzbekistan, and currently we need to go to the other countries to implement our project.
Thank you, Dr. Achal, for asking a good question. Government of India has already legalized in a way that the telemedicine opinion can be given. It's already is being practiced in India. We were doing for our institute since 2015, and I think I'll remove the mask for a second. I think many corporate hospitals were already doing and connecting to the hospitals in the cities, small cities and districts. One of the major issues which we all face is the bandwidth of the network. That's very, very important issue. But this is very practical, and COVID-19 has really taught us the new normal and how to get connected with our patients. We are doing on regular basis at global level, patients who are within the country or outside the country, and connecting with the doctors for the telemedicine, which can be further done into teleneurology, telecardiology, or radiology. So this is being practiced on regular basis. And as far as the COVID-19 reports are concerned, every day we are doing around 600 to 700 rapid antigen tests and RT-PCR. So they have to be uploaded the same day on the ICMR portal, that is Indian Council of Medical Research. So these things are improving by every day, and we are learning new things, and we are learning to live in new normal. Thank you so much. Thank you.
Thank you.